Thermo time, welcome. We've got a new video for you here today. Let's see, name of this video is specific volume and U versus H. Now we've heard a little bit about specific volume, but let's call it out directly here. The first is that specific volume is volume per, what does specific mean again? Per unit mass. Or specific volume, little v, is volume, big V, over m. Now, we've seen this relationship before, back in chemistry and other places. Density is mass over volume. So if V is volume over mass and rho is mass over volume, then V is 1 over rho. There's an inverse relationship between density and specific volume. Where have we used it so far? Well, we have used it in the definition of enthalpy. It is a convenient grouping of U plus PV, and the V here is specific volume. We've looked at temperature entropy diagrams before, and they're useful to show that as you move across the vapor dome, the entropy goes up. It's also true that specific volume does the same thing. So the specific volume of a subcooled liquid is low. The specific volume of a saturated liquid, we'll actually start using steam tables, and we call that VF. As we add heat, specific volume goes up to VG, and then this would be V of a wet vapor and V of a superheated vapor. Just using this to show you that the specific volume of water increases as it heats up and boils and continues to heat up. All right, specific volume, check. Now we're going to do a little conversation of internal energy versus enthalpy. In a thermo book, if you look through a thermo book, you'll see sometimes they say that the heat transfer is delta U. Sometimes they'll say delta H. We're going to see if we can find the difference and what causes the difference. First thing I would like you to do is press pause and write out in your video notes the steady state first law rate equation. Pause. Welcome back. You should have, in some algebraic order, rate of heat transfer in minus rate of heat transfer out, mechanical power on minus mechanical power by, mass flow rate in times all of the stuff it brings in, minus mass flow rate out times all of the stuff it brings out, equals 0. You could have had these written in different orders here. You could have had some stuff on either side of the equal sign. But so long as we are equivalent, we're good. Now, let's simplify this if we were going to just transfer heat into something. So there would be no heat transfer out, no work. And in thermo, we end up canceling out these PEs and KEs. In fact, if you wrote it without the PEs and KEs, okay, no problem. So we get Q dot N equals M dot delta H. So what if we were to consider a boiler? In a boiler, we bring in some liquid, and we apply some heat, and it leaves as a vapor. Does its internal energy change? What do you think? Those molecules have more energy when you've boiled something? Yes, they do. It goes up. Does the pressure change in a boiler? The answer to that is not very much. But does the specific volume change when you boil something? Yes, it does. It goes up. So if you are going through a phase change and you want to know how much heat is going in, you would multiply the mass flow rate of the fluid times the H out minus the H in. Okay, well, let's contrast that. Let's have a heat exchanger where we're concerned with the fluid that's flowing through a pipe and not going through a phase change. It's just being heated up a little. Does its temperature go up? Yes. Does its pressure change much? No. Does the density or specific volume of a fluid change much over a temperature change with no phase change? And the answer is no, it really doesn't. So in this case, a delta H and a delta U, delta H would be the same as delta U. Up here, delta H would not be the same as delta U because the PV term is changing a lot. But when the PV term doesn't change, the only thing that's changing in the H is the U. So we could say Q dot equals M dot delta U, U out minus U in. So, in summary, delta H and delta U will not be the same if the pressure or volume are changing. Delta H and delta U will be the same if the pressure and specific volume are not changing. And in a thermodynamics course, you'll see examples of both. That's that. See you next time.